Greeting to our lecturer, Madam Christie. I would like to present our mini project. Before starting the presentation, I would like to introduce my group member. First one, Olivine Joy, and me, Terence Shaw, and third, Adriel, and last one, Efrain Aurel. Application of HCC HMS software. First, flood forecasting and analysis. HCC HMS model rainfall and runoff to predict flood events, helping engineer design effective flood control, measure and reduce damage. Second, watershed management. It evaluates water flow and soil within a watershed, supporting sustainable water use and land management. The third one, stormwater drainage design. The software helps design efficient urban drainage system to manage excess rainwater and prevent flooding. Next, reservoir and dam operation. HCC HMS assists in managing water levels, release, and storage to balance flood control. Now, let's move on to the benefit of using HCC HMS in the hydrology field. First, it offers high accuracy in simulation, producing reliable rainfall runoff and hydrograph results. Second, it has a user-friendly interface which makes model creation and data input much easier. Third, it's freely available, so both students and professionals can use it without cost. Fourth, it's integrated with GIS tools like HCC Joe HMS and HCC RAS, allowing spatial and hydraulic modeling. And lastly, it supports decision making, helping engineers design flood control structure, drainage system, and water management plan based on accurate data. Lastly, let's look at how HCC HMS relates to environmental sustainability. The software promotes responsible water management, ensuring water is used efficiently and not overexploited. It helps in reducing flood risk by providing accurate hydrological models for flood control system. HCC HMS also supports sustainable urban planning through green infrastructure such as permeable pavement, detention basins, and green roof. Moreover, it helps in assessing climate change impact, allowing us to understand how rainfall and runoff patterns might change in the future. Finally, it contributes to protecting natural ecosystem by maintaining watershed balance and preventing human-induced disturbance. In short, this software not only supports hydrological analysis but also plays a key role in sustainable water and environmental management.
Create new project, name our catchment, description is 25 ARI 3 hours. The default unit is metric. Go to component, create component and new basin. The name is 25 ARI 3 hours. The description is also the same. And then create another component meteorologic model. Name and description also the same. Control specification, name and description is also the same. For time series data, put the name Gunung B. The description is also Gunung B. The data type is precipitation. In the attachment, go to basin model, 25 RE 3 hours, and create new subshading element, name and citation. Description is C1, and add a new submission for C2, and add C3. Select scene creation, create new scene element for S1, and then connect them. Also connect C2 and also C3.
C1, go to area 1.07, initial loss. We put 10.0, the rate we put 3.0, and the impervious we put 30%. At the transform, the concentration we put 0.34 and the coefficient we put 0.57. At best flow, the discharge is 0.09. The constant is 1 and the ratio is 0. Go to C2 and the area we write 0.76 and the initial loss 10.0, rate 3.0, and the impervious is still 30%. Transform, concentration we put 0.5, coefficient 0.5, and best flow discharge 0.1, constant 1, ratio and 0. At the C3, for the area we put 0.85. At the loss we put 10.0, rate 3.0, impervious still 30%, and at transform concentration 0.6, coefficient 0.5, best flow. At discharge we put 0.1, constant 1, ratio 0. At the S1, SC1, go to basin and collect VHRAS and specified on the graph. Gauge is gauge 1 for all. At the 25 RE 3 hour, the date we put 1 December 2022, and for the time 0, and for the date same, and the time is 12.
First, we go to time series data, gauge 1, time interval 15 minutes, and we change start date 1 December 2022 and end date 1 December 2022. And end time 12, we go to table, precipitation, we insert data from the question 1.400, 3.00, 3.50, 4.0, 6.20, 10.00, 13.0, 25.0, 20.0, 15.0, 10.0, 6.50, 4.30, 2.30, 1.50, 1.10, and then other is 0. And then we go to basin model, compute, create compute, simulation run, next, finish, and we go to compute, simulation run 1, we go to ratio, state, simulation run, and run the program. Go to result, simulation run 1, global summary result. This is the result. We go to C1. This is the sub-basin graph for sub-basin C1. Summary sub result, time series result, outflow, cumulative flow. We go to C3, summary table, C2 graph, summary table, S1, summary table,